Good evening, all of you. Welcome you guys. Good evening to all of you. Welcome you all. So कैसे हो सभी लोग? I hope all of you are doing great. So here and so tell me, is my audio video is clear to all of you? Audio video is fine to everybody. Please do comment. So whether please check the audio video. Is it fine? Chalo. So let's welcome you all. Welcome to this EMFT classes. So chalo, let's continue our discussions. And we have a great announcement to all the aspirants of GATE 2023. So to know the mistakes, to know what are the mistakes you can commit, for that purpose we are providing this all India mock test. In this mock test, whatever the mistakes are, you can do, and you will do your mistakes and rectify your mistakes, then so that you cannot repeat your mistakes. And this coming Sunday we have all India mock test is there. All of you do enroll for this mock test, link given in the description, and you can use the invite code B V Reddy. There you can use the invite code B V Reddy. Fine. So with this you will get the great experience, real great experience आपको मिलेगा, and all these questions and solutions was prepared by the top educators, and it is 100% error free, and you will get to know the complete video solutions also after completion of the exam, right? And you can have a look at now. Here you can plan this Unacademy subscription with a no cost EMI. So we have the complete notes are available, complete materials available in PDF form. You can access the material, and these are the new batches we are starting for the 2024. Have a look at here. The new batches are commencing here. You can see the top educators will take the classes. You can plan your Unacademy subscription with no cost EMI, and these are the Unacademy plus features and iconic features. If you have taken the plus subscription, so then you can able to avail these features. You can access the top educators, all the top educators classes. You can access digital notes, test series, and iconic students will get the additional benefits: customized doubt solving, one-to-one mentorship, strategy and study programs, and interactive open house session. These are the additional benefits of iconic students. Fine. Chalo, let's continue here. I think last class we did the electric field due to the point charges, line charges we have completed. All of you tell me, point, line, surface charges we have completed now. Everybody clear? Any doubt you tell me? Out till this? If we have कोई doubt हुआ तो बोलिए. And we have seen some problems also we have discussed, isn't it? We have discussed the problems also. Fine, all of you. Chalo, let's take the next problem. Take the next problem. Three infinite sheets of charge densities. The three infinite charges have a charge densities given 18, 9 and minus 24 nanocoulombs per meter square. All these are what type of charges you can see? All these are what type of charges you can see? All these are the surface charges. All these are what type of charges? Surface charges. Now, So in this session, as of now, I'm planning for the planning for this as up to static parts, up to the Maxwell's equation have planned, and after that we'll cover the remaining topics. As of now, in this session, I'm planning the only the this is up to the static fields. The common syllabus for the ECE and electrical I'm planning, and the topic which is only for ECE then we'll see later. As of now, I didn't plan that one. Now, if you have a plus subscription, you can watch in the plus classes you can watch, and even I have taken the special classes also I completed. You can watch. You can search my profile in Unacademy. You can search my profile B V Reddy. In the free classes completely have covered. Okay, you can search there. So I have covered this as a I have covered the networks. I have covered networks completely digital. So I discussed all the problems including DPP I have covered, and then controls I have covered, problems I have discussed, and signals and systems also covered, and EMF DPP also have covered. Complete course as well as a DPP have covered, and the maths also. Engineering maths, all the topics have covered: probability, linear algebra, calculus, differential equations, complex variables. I have covered all the topics. Fine. You can search my profile. You can search my name simply B V Reddy. There you can get my profile, and you will get all this class links you can get now. If you have a plus subscription, you can watch the plus classes. If you don't have plus subscription, you can go for the special classes. You can watch it. Fine. Listen carefully. I have a 3 infinite sheets they given. So one charge which is located when x is equal to 4, this having a charge of how much, you tell me, rho s na here, how much it is, 18 nanocoulombs per meter square. And when second charge is what now here on y axis, when y is equal to -3, it has a charge of what, you tell me, rho s, how much, you tell me, that is 9 nanocoulombs per meter square. And when z is equal to z is equal to 0, sorry, z is equal to 0, can you tell me how much is rho s value? Which is equal to -24 nanocoulombs per meter square. Fine, all of you tell me this thing. This is the data that has been provided. Now here they given this is x is equal to 4 plane na? This is the plane, and y is equal to -3 plane. Hana boliye. And z is equal to 0 plane. All these are the plane na? Plane का मतलब क्या है? Surface. Plane का मतलब क्या है? Surface. Now, so if I say this as a x is equal to 4 means what is that plane here? X is equal to 4 mean that is called as yz plane. हाँ ना बोलिए. X is equal to 4 मतलब क्या है? That is nothing but yz plane. Can you tell me which is perpendicular to this yz plane? Which axis is perpendicular to this yz plane? Tell me. X is equal to 4, इसका मतलब क्या है? So that is nothing but what, you tell me? बोलिए यार. So x is equal to 4 means which is nothing but yz plane. हाँ ना बोलिए. x value constant. बोलो यार कुछ, कभी तो हाँ ना बोलना पड़ेगा. समझ में आ रहा कि नहीं? x is equal to 4 plane means that is a x value constant, y and z values we have changed. So that is a yz plane, and which is perpendicular to x is equal to 4 plane, that means yz plane, which is normal. So x axis is a normal. If I write this thing as en cap, unit normal vector, which will be given as, it may be what I can say now here, ax cap. हाँ ना बोलिए. and this Ax cap, it may be positive, may be negative, that depends upon where you are finding the field. Ax, An cap, which may be a positive, may be negative, that depends based upon the problem. Now you tell me now here y is equal to -3 plane. So इसका मतलब क्या है? This is nothing but what I can say now here. This is nothing but xz plane. बोलिए. This is what we can say now here, xz plane. And which is normal to xz plane? Which is normal plane? Which is nothing but y-axis. AY. So this is, it may be positive, may be negative. It may be positive, may be negative. बोलिए. Next, z is equal to 0 plane means what plane? You tell me now, which is nothing but xy plane. बोलिए. xy plane. Now you tell me now, which is normal to xy plane? Which is normal to xy plane? So that is nothing but az cap. ये बात क्लियर हुआ? बोलिए सभी को. Is it fine? Tell me. Now, so I want to find the electric field at a given point. The electric field at the point given as like this 8, 0, 6. So the electric field at this point is because of the discharge, because of discharge, because of the charge. All the three charges I can say. And all the charges, what type of charges these are? And what type of charges are these? What type of charges these are? What type of charges these are? Tell me now here. Surface charges. What type of charges these are? Surface charges. And tell me what is the electric field due to surface charge formula? Basically, electric field due to surface charge, basically the formula which is given as what we can say, tell me now here, rho s by 2 epsilon, rho s by 2 epsilon into En cap, rho s by 2 epsilon into En cap. So now here I need to find the electric field because of the all the three charges I need to get. I need to find the electric field because of the all the three charges, isn't it? Now tell me now here. So if I call this electric field E, which is given as electric field due to the charge 1 plus electric field due to the second charge plus electric field due to the third charge. बोलिए. So we are finding the electric field due to the all the three charges. Now tell me E1. What is this E1 is a? What is this E1 is a? Electric field at what point we need to find? You tell me. At this point. This is the point where we want to find now. This is 8, 0, 6. This point is given. At this point we have to find. Tell me the electric field due to this charge which is given a surface charge. Now tell me. So what is the formula? Tell me. Rho s by 2 epsilon. How much the rho s value here? 18 by 2 epsilon. Rho s by 2 epsilon into what I can say, En cap. What is this En cap is a unit normal vector. So which is a normal vector? Here we got this as Ax cap. And we need to decide whether this is the positive or negative. हम decide करना पड़ेगा. Now you see this thing here. Where you want to find the electric field? You tell me here. I want to find this point here. So this is here. My charge is at x is equal to 4. Now at this point you see the just x coordinate only. Just observe the x coordinate only. So now this point x value 8, my charge is at 4. That means where is this point now here? Above the charge or below the charge? Where is a x is equal to 4? Now point is whether this is above the charge or below the charge. Clear? Whether this C is above the charge or below the charge. Yes, 8 is above. This is the point. This is the point P. Now I am finding the electric field where now? Yes, charge के ऊपर, charge के नीचे. We are finding the electric field above the charge or below the charge, I am asking. Charge is at 4. Charge is at 4, yeah. And so 8. We are x value 8. That means obviously we are finding the electric field above the charge only. Now tell me. We are finding the above the charge. So that's why it is a positive. बोलिए. We need to see the point P where you are finding the field. Next, E2, tell me. So the second charge here, this is a 9. So we can say here plus 9 by 2 epsilon. Tell me the unit vector is a AY cap. AY cap. Now you tell me now here. So tell me now here. So here this y value, how much you tell me? Minus 3. Here y value, what you tell me now? What? See only the y coordinate only. Y value, how much you tell me? 0. That means we are finding the field above the charge or below the charge. We are finding the electric field above the charge or below the charge. So here this is 3 we are finding. So here we are finding the field at 0. Yeah? So here this point is minus 3. Minus 3. So the point P. Yes, 0 lies above minus 3 or below minus 3. Where is the 0 lies now here? Above minus 3 or below minus 3? We are finding at 0. 0 lies above now here. Above. So that's why which we can call this as a positive. Tell me. Anna. बोलिए. Next one, third charge is they given as a negative charge is there, that is minus 24 by 2 epsilon into, tell me, En cap. Tell me En cap now here, which is equal to Az na. En cap, which is equal to what you tell me now here? Minus 24 by 2 epsilon into what I can say now, this is Az. Tell me now here. So here now tell me whether plus Az or minus Az. Plus Az or minus Az. I am finding the here where the Z value here. Z is equal to 0. I am finding Z value how much here? Tell me now. Z is equal to 6. Z is equal to 6 lies above the charge or above or below. Z is equal to 6 lies above or below. It lies above na here, so I can say this as a positive. हाँ ना बोलिए. आया कि नहीं सभी को ये बात? Is this point clear now, everybody? This is the way we need to solve the problems. In this manner we can find the electric field due to the surface charges. Done? Chalo? Let's move to the next problem. And regarding the complete notes and DPP and material short notes, and you do follow me in the Telegram channel, and you can follow me in the Unacademy also. In the Unacademy app, you can search my name. So you can search my name B V Reddy. You can able to get my profile. You can able to get my profile. In the Unacademy you can search this thing. And if you want this thing here, Telegram, in the Telegram you can follow me. In the Telegram you can follow me. You can search the name B V Reddy GATE. Yeah, here you will get here B V Reddy GATE. Here you will get completely. So you can search the name B V Reddy GATE. In this B V Reddy GATE, so I will upload this complete notes I can able to upload. You will get the complete notes is available in the Telegram. You can search the name, so B V Reddy GATE. There you can find the, so complete notes is available. Yeah. यस, ये इलेक्ट्रिकल ब्रांच के लिए बहुत इंपॉर्टेंट है. सो इलेक्ट्रिकल का पूरा सिलेबस मैं कवर करने वाला इधर. सो यू कैन गेट द कंप्लीट फुल नोट्स मिलेगा. कंप्लीट नोट्स मिलेगा एंड यू विल गेट DPPs. You will get DPPs and you will get the short notes BI. And what we can do here, after joining in this group, then you can go to the file section. File section you will get this completely. And so here even we have a DPP. So I have discussed all the DPP questions. Nearly 400 problems are there. So nearly 250 problems I have discussed. All the problem DPP solutions links also available. You can get the DPP solution links. DPP solutions links are available. I discussed all these things, the special classes. These are free classes. In free classes are covered. You can able to access it. DPP solutions links you can able to get there. Fine. Right. So here and so many initiatives we have. Yes. So here the potential for the surface charges is that formula which is tending to infinity. So that's why I have not given. So here this is the rho s by 2 epsilon we have seen. This is the potential electric field we have calculated for the infinite charges. This we have calculated for what type of charges are infinite charges. This is for infinite charge. As the charge is tending to infinity, potential will become infinite. So all this analysis we are doing for what type of charges are infinite charges, not finite charges. If the charges are tending to infinity, then in that case potential also will be tends to infinity. That's the reason I didn't given the formula. If it is a finite, then we have separate derivations are there. Okay. Chalo. Take this problem here. The ratio of the charges stored by two metallic spheres raised to the same potential is 6. Then the ratio of the surface area of the sphere is. Now the ratio of the charges with the two metallic spheres raised to the same potential. So here the potential raised to the same potential is given as like this. Means what they are saying is that two potentials they are saying equal. They are saying, now tell me all of you. They are saying that the two potentials are equal. Hana boliye. And what is the potential due to the spheres, you tell me? Conducting spheres KQ1 by, I can say R1, which is given as KQ2 by R2. Hana boliye this thing, tell me. and they has given that the ratio of charges given, that means they given the q1 by q2 given, they given the q1 by q2, they given this as a 6, right? So from this here we can get the q1 by q2, and which is equal to what I can say here, r1 by r2. So from this I can write this r1 by r2, I will get now here, which is equal to 6 by 1. These are the radius of the spheres. Now, so what they asking to find, you tell me here? They asking to find the surface area. What is the surface area of a sphere? Which is given as 4 pi r square na? Surface area of a sphere, which is given as 4 pi r square. So what I can say now, this is S1 by S2, the ratio which will proportional to, I can say, R1 by R2 ka whole square, R1 by R2 whole square. So what I will get, you tell me now here, S1 by S2, which is equal to 36 by 1. So कौन सा option? C. Done. चलिए next one. Spherical volume charge. Spherical volume charge. Yes, volume charge. We have a sphere. Spherical means we have different type of spheres. We have, let's talk about the brief introduction about this thing here. And we have a one, we used to call this as a conducting sphere. I can write this thing as a, one second, solid conducting sphere. All of you tell me, solid conducting sphere. Solid conducting sphere means this is the solid, this is the solid completely. So here which is a solid conducting sphere, having a charge. Now you see this thing, for this solid conducting sphere, let us consider I have given charge, some charge q is given to this sphere. Then see what's going to happen. I have given some charge q to the solid conducting sphere. What's going to happen? Whatever the amount of charge I have given to the solid conducting sphere, so the charge will completely lies on the surface of a conductor. So as we know, charge cannot enter into the conducting sphere. Hana bole, whatever the excess amount of charge we have given to the conductor, the charge will resides, will lie only on the surface of a conductor. So that means the charge completely lies only on the surface only, the charge cannot penetrate into the conductor. Fine. This is for in case of a solid conducting sphere. Now let us see the second one, that is halo. Halo conducting sphere. Halo conducting sphere, if we have considered, you tell me how this halo conducting sphere. Halo means inside part is empty na? Inside part is empty. Here also this is the conductor. I have given some charge q is given to this on the surface now here. You tell me now where the charge will lie. Since it is what now conductor, this conductor also does not allow any charge to enter into now. This conductor also does not allows any charge to enter inside the conducting sphere. Hana boliye. So the charge will lies only on the surface only. Is it fine? Now let us consider third case. This is a halo non-conducting sphere. If I call this as a halo non-conducting sphere, right? So this is a halo non-conducting sphere. Halo, and let us say this radius now here. Now you see this thing here. I have given some charge Q. I have given some charge Q to here. Now you tell me क्या होगा इधर. So this is a halo non-conducting sphere. Halo and non-conducting sphere. So since it is a non-conducting sphere, this non-conducting sphere will try to allow the charge into the non-conducting material. But लेकिन क्या होगा inside इसके अंदर. So here पूरा खाली है ना, इसके अंदर पूरा खाली है ना, here कुछ भी नहीं ना, मटेरियल तो नहीं ना. अगर मटेरियल नहीं तो here charge cannot able to penetrate. Charge cannot able to penetrate. हाँ ना बोलिए. As a result, where the charge will lie? As a result, where we have a charge, you tell me. Charge will, yes, charge will lie where, you tell me. In this case, also charge will completely lie on the outer surface only na. Outer surface and inner surface only. The charge will lies only on the surfaces only, but the charge cannot enter na inside. Hana boliye. Right. So next one, what is the last case is available case? You tell me fourth case if I say, which is given as a solid non-conducting sphere. Solid non-conducting sphere. अभी बोलिए क्या होगा? For in case of solid and non-conducting sphere, क्या होने वाला? This is a sphere of radius is capital R. This is solid. Solid now here we have material, and which is a non-conductor also. Now if I have given some charge Q, now you see what happens now here. Here it is a non-conductor. Since it is non-conductor, will this non-conductor allows the charge to enter? Will it allows the charge inside or not? Will it allow the charge to enter or not? Non-conductor can allows, and we have material is also there now. That means we have inside also we have a charges present. Hana boliye. So we have the charge can be present inside also. Everybody tell me. The charge will distribute on the inside also. The distribution may be uniform and may be non-uniform. Is it fine, all of you? Done. Now if you see the things now here, in the case 1, case 2, case 3, in all the 3 cases you see this thing here. What you observe now here, all the 3 cases, the charge will lie completely on the outer surface only. Charge will lie completely on the outer surface only. Hana boliye. If the charge will, the electric field depends upon what now? Charges only na. If so, that means what we can say, the electric field expression what we are going to see, electric field and potential for the case 1, 2, 3 all are same. Case 1, 2, 3, the relations, formulas what we are going to see, all these are same. Is it fine? Done. Now let's see this thing here, electric field due to all the three. After fourth one is a special case, that is the most important thing that आगे हम देखने वाला. Now first of all let's talk about all these things now here. Now I am finding the here the expressions whatever I am going to do, those expressions are same for all these things. What are the spheres here? One is a solid. Inside surface lies, that is also lies inside. In all the cases inner layer outer layer will lies. In all the three cases inner layer outer layer can lie charges, remember. Okay, so charges will lies in the inner layer and outer layer, that is just before it is no charges. Exactly on the surface we can say, exactly on the surfaces only we have charges. Now so first one is a solid conducting sphere. Solid conducting sphere. Next one, hollow conducting sphere. Next one is a hollow non-conducting sphere. All these three cases the analysis what I am going to do is same. Done. Now this is my sphere having the radius. I am calling this thing as a capital R. I have given some charge. Where the charge will lie, you tell me. On the outer surface only. Charge will lies only on the outer surface only. Now you see this thing here. Now I have to find the electric field analysis we need to do. To find the electric field, what we'll do here, we use a Gauss law. What we'll do, we use a Gauss law. So here I want to find the electric field inside the sphere. That means what we can say here, any point, random point, 0 less than R less than capital R. That means what now here, 0 to capital R inside the sphere. As well as I need the electric field outside the sphere for small r greater than capital R. Ana boliye, small r greater. That means where the small r is a distance now here. If I want to find the electric field here, then this distance is called as a R, isn't it? Now if you see carefully, now if I want to find the electric field inside the sphere, what I should do here, we need to take the Gaussian surface. Now tell me, we'll take the Gaussian surface. Now you tell me, now this, if you have taken the Gaussian surface on inside the sphere, tell me what is the amount of charge present inside my Gaussian surface. So here at this location, so what the charge lies inside my Gaussian surface, completely 0 now. If the charge is 0, what I can say, my electric field is 0. Electric field is 0 for where to where, you tell me now here, up to 0 to my surface of a sphere. Hana boliye. Done. And if I want to find the electric field here, if I want to find, you tell me this is, now I should call this is a R now. Now what I should do here, with this much of radius we should draw Gaussian surface. How can you tell me what a charge enclosed by the Gaussian surface? Now Q enclosed, how much charge inside my Gaussian surface? The total charge lies inside only now, tell me. A pura charge inside my Gaussian surface only now. So which we can say Q enclosed equal to Q. So tell me what I can say, this is 1 by 4 pi epsilon into, that is Q by r square into ar cap. This is an electric field inside and outside. Inside, how much the electric field you tell me? 0. And we have the electric field completely lies on the from the surface onwards, electric field is non-zero. If I draw this variation of electric field with respect to distance, you tell me now how we have a plot, you tell me. Now this is the distance along x-axis we have taken, and this electric field magnitude along y-axis. Now up to a distance of when small r is equal to capital R, up to a small r equal to capital R. So here what is the electric field now? Just before the surface, electric field is completely zero. Completely zero. Just before R, electric field is completely zero. And exactly at R equal to capital R, it will go to the maximum value. Suddenly will reaches to like this. Okay. Thereafter, this electric field decreases. Thereafter, electric field decreases. So how much this field here we can say, which is given as kq by r square, I can write at these locations. Thereafter will decreases 1 by r square. Now अगर आपने ध्यान से देखा तो here this is now the electric field just before r. How much the electric field? Electric field at r is equal to r minus. How much the electric field you tell me? Which is equal to 0. Electric field just before 0. And what is the electric field at r is equal to r plus, which is given as something, some value na here, which is non-zero. It has some maximum value na, tell me. It has some maximum value. Hana boliye. Now you can see now here the electric field just before 0, just after is non-zero. That means what we can say here, so left limit is not equal to right limit. Left limit is not equal to right limit, so we can call this as a electric field is a discontinuous at the center of the, sorry, at the so at the surface electric field is a discontinuous in nature. Suddenly will rises na here. Suddenly this value will rise to high. So that is a, we have sudden impulse. We have impulse means it is a discontinuous. Boliye. These are what you tell me electric fields. These are what you tell me electric field. Now let's talk about the potential. Now let's talk about the potential. Now as we have seen earlier also, for the conducting sphere, conductor is what you tell me, what is a equipotential surface potential at any point on the surface of a conductor is same as the surface potential. So the potential V, which is given as what we can say, that is kq by capital R. This is the potential for what we can say 0 less than r less than or equal to capital R, and which is given as, we have discussed this thing previously also. So that is for r greater than capital R, whichever is a bigger that will take. Now tell me all of you. Now so if I draw this variation of potential with respect to distance, can you tell me how the variations here with respect to distance and potential variations? So this is, here is r equal to 0. The potential, which is a constant here, tell me, which is a constant up to where, you tell me, up to small r equal to capital R. Thereafter it is inversely proportional distance na here, that will decrease like this, which is given as kq by r. Everybody, and all of you do like the session. Everybody, all of you do like the sessions. Done? बोलिए now here. चलिए, what is a conductor here? Potential here. What is the potential the conductor, you tell me? All these things are behaving like a conductors only now. We don't have any charge lies inside only. Complete charge will lies where, you tell me? Total charge lies where, you tell me? Outside only now, tell me. The total charge will lies. The total charge lies. All these things are behaving like this one, all these are comes under same category, you see. Now, so for the solid conducting sphere, we have discussed yesterday while discussing the properties of a conductor's potential analysis हमने किया. Potential analysis हमने किया. So if I want the potential, so this radius is a capital R. If I want the potential at this point, this distance is small r. Tell me what is the potential at the point here, tell me. Whichever is a bigger, that has to be taken or not. The potential, yes, inside the spheres are constant. We have outside only we have. Here, this potential when you have written, here which is a variable parameter here? What is a variable parameter? Small r, capital R is a variable parameter. Which is variable parameter. Small r is only the variable parameter. Capital R is a radius of the sphere, which is a constant or not? Capital R is a radius of the sphere. Radius of the sphere is always constant. Radius of the sphere constant. Small r is only the variable parameter. Right. So here there is no small r parameter, you see. There is no small r. So the potential irrespective of a distance is constant होना पड़ेगा. It is irrespective of a distance, it should be a constant. Here this is inversely proportional, so that's why it is decreasing like this. Chalo. Now let's talk about, we have discussed about all the three cases. Now let us say fourth case. This is the most important thing. What is the fourth one we have seen? Tell me, all of you. What is the figure, you tell me? This is solid non-conducting sphere. Solid non-conducting sphere. Mostly we can expect the problems on this thing. Solid non-conducting sphere. In the problem, if they not mention what type of sphere, here we have the four type of spheres, so then by default you assume this as a solid non-conducting unless they don't mention. If they don't mention what type of charge is it a, you consider this as a solid non-conducting sphere, we can consider. Fine. Now here consider we have, this is my solid non-conducting sphere having this radius, which I am calling this thing as a capital R. Now since it is a solid non-conducting sphere, inside also we have charges present. Now tell me, if you have given charges will present inside also, right? Now, so due to the charge, now I want to find the electric field inside the sphere as well as outside the sphere we need to find. Now we have the electric field formula, we know now. What is the electric field formula? Which is given as 1 by 4 pi epsilon into what we can say here, Q by R square into ER cap. Isn't it, all of you? This is the basic formula here. So whenever the spherical charges we have according to Gauss law, where this Q is there now, Q we can convert in the form of a Q enclosed, we can make it, where Q is equal to what? Q enclosed. What the Q enclosed means? The charge enclosed by the Gaussian surface. What is the Q enclosed? Is the charge enclosed by the Gaussian surface, right? Now due to this I want to find the electric field inside as well as outside. Let us say I want to find the electric field here. So with this much of radius I should draw a Gaussian surface now here. that amount of charge we need to find. If I want to find the electric field here, so with this much of radius, I need to draw a Gaussian surface. With this much of radius, we need to find the Q enclosed, we need to get it. All of you. Now, अगर आपने देखा तो here this is having a charge. What type of charge it will contains? If I consider this will have a charge of Q. Now I can define the term called as rho v. I can define now rho v, which is given as Q by what I can say here 4 pi r cube. That is a coulombs per meter cube. Rho v is given as Q by 4 by 3 pi r cube. No? Sorry. So this is a so here this is a volume, total charge per total volume. Now you tell me now here. So case 1, I have to find the electric field. Where you tell me? We are finding the electric field from R value lies between 0 to capital R. If the R value lies between 0 to capital R, can I find the electric field? You tell me. I need to get the total charge enclosed we need to find. Can you tell me charge enclosed here? So that means here we need a charge up to my Gaussian surface only required. This small part only required. Now tell me. I need to get the charge up to my Gaussian surface. And this is my density we have. So the density which is given as what we can say, this is rho v into the small, this radius is smaller, and I can say, so this part of the charge only we need to consider or not. And the density is a rho v, it is a uniform we have taken, and then volume is given as what we can say, tell me 4 by 3 pi small r cube होगा ना, tell me. Is this point clear? बोलिए. 4 by 3 pi small r cube. Is it fine? Right. Now, so here this Q value I can substitute here in this formula. So can you get the electric field now here by substituting here? Substitute the Q value here, get the value of electric field. Simplify, tell me the value, which will get this thing as R rho v by 3 epsilon into ER. R rho v by 3 epsilon into ER cap. Check all of you. Did all of you got the same thing or not? बोलिए. कोई doubt हुआ तो बोलिए. Now you tell me now here. Now I want to find the electric field where? So outside I need to find. That means what I can say, small r value greater than capital R na. Now this is my small r. Now you tell me now. In these cases, tell me now here. Can you tell me my Q enclosed here? Can you tell me Q enclosed now here? I have taken, this is my outer one is my Gaussian surface. Yes, these red ones are what you tell me, these are the Gaussian surfaces now. Now you tell me now what is the charge enclosed by the Gaussian surface, tell me. What is the charge present inside my total charge is inside only now. So Q enclosed is given as a Q only. Fine all of you. So that means Q. So I can write the formula. So electric field E, which is given as, so Q enclosed we can replace now here. That is 1 by 4 pi epsilon into Q by R square into AR cap. बोलिए. This is the electric field inside and outsides. Is it fine? here also we can do some modifications also we can do here, where this Q is the charge form. So from this relation, can I get the Q here? I can get the Q here. Q is given as rho V into 4 by 3 pi r Q. And in place of Q, I can replace now. I can simplify now. By simplifying this thing here, you can get the relation as like this. So the electric field inside, which is given as ROV by 3 epsilon into AR, and this is the electric field for 0 less than R less than capital R. Now if I replace this R value here, we'll get this thing as R cube rho V by 3 epsilon into R square into AR cap. This is the electric field outside the sphere. How we got this relation? ये कहाँ से आया? How we got these relations? Simple यहाँ से. So here from this only we got it now. Here Q is there now. Q, in place of Q, replace rho V into this much and simplify, you will get these relations. Nothing else. Is it fine? These are the electric fields inside the spheres. Fine? Inside and outside. Now coming to the potentials. The potential inside and outside. Rho s, here this is volume charge, yeah. What is the rho s is? Rho s is the surface charge, na. Rho s means what now? Surface charge. Surface charge density. Surface charge density, for in case of a plane surfaces, we can use the surface charge density, that is two-dimensional figure. That is rho s is given as what we can say now here, charge per area. Charge per area, 2D figure. And this rho v is given as what we can say, charge per volume. Now 3D figures will define the volume charge density. Okay, coulombs per meter cube. 3D dimensional figure will go for the volume charge and 2D figures will go for line charge, surface charges. And coming to the potential inside, which is given as rho v by 3 epsilon into 3 r square by 2 minus r square by 2. This is the potential for 0 less than small r less than capital R. And outside, which is given as rho v into r square by 2 epsilon. This is for R greater than capital R. These are the potentials inside and outside. This is the potential inside. This is the potential for inside the sphere. This is the potential for outside the sphere. Done? Now, let us say here I want the potential at the center of the sphere. Can you tell me the potential at the center? Potential at the center of the sphere. To get the potential at the center of the sphere, I should make this as small r equal to capital small r equal to 0 now. How will get the potential at the center of the sphere? I will make the small r equal to 0. If I replace small r equal to 0 in this equation, this term will become 0. 3 will get cancelled. So then what I will get, you tell me. So what I will get, you tell me. Which is given as, बोलिए. That is rho v r square by 2 epsilon. Done? Can you tell me the potential on the surface of the sphere? Potential on the surface means what I will do here, small r, I need to place it as a capital R now. On the surface means small r equal to capital R, I need to place now radius of the sphere on the surface means. If we place it now here, then see what I will get. All correction, rho v r square by 3 epsilon into small r. Sorry, do correct it. This is the formula. Do correct this formula here. I have given 2 given. It is not 2, it is a 3. Do correct it. Sorry. So this is rho v r square by 3 epsilon into r. Do correct this formula. Okay. Now tell me now, when small r equal to capital R, how much the potential you tell me? What are the potential on the surface now tell me? Which is given as rho v r square by 3 epsilon will come now. Check this thing. Now can you tell me the relationship between the two potentials now here? I can say the potential at the center, and which is equal to 3 by 2 times of potential on the surface. I can say potential at the center, which is given as 3 by 1.5 times the surface potential. The center potential is 1.5 times the surface potentials. All of you बोलिए. Done? Now take this problem. A sphere of radius capital R having a charge density rho naught coulombs per meter cube. Then the ratio we are discussing this potential for what type of charges, you tell me. What type of spheres we are talking, you tell me. What type of spheres we are talking, you tell me. Is it conducting or non-conducting? How I am discussing now here. What type of spheres we are talking, you tell me. Solid non-conducting sphere. So previously we have discussed. Previously this is the conducting sphere. These all the three we have discussed now. Now we are discussing for what type of spheres. Solid non-conducting sphere. Is a non-conductor is a, am I told the non-conductor is a equipotential. Conductor is a equipotential. Non-conductor is not a equipotential. We are discussing about the non-conductor. Remember, all the formulas we have given for non-conductors this analysis, not for conductors. Now, a sphere of radius capital R having a density rho naught. So here they didn't mention what type of sphere is it. If they are not mentioned, we should treat this as a solid non-conducting sphere. Without mention, we can treat this as what you tell me, solid non-conducting sphere. If there is mention, consider, otherwise take it as a solid non-conducting sphere. Now they are asking to find the electric field. Where they are asking to find the electric field, you tell me here. Where small r is given as a capital R by 2. And they are asking to find the electric field where small r is given as what we can say 2r. They are asking to find a ratio between these two. Hana बोलिए. Now अभी हमने देखा, so the electric field inside and outside we have seen ना. What is the electric field inside the sphere, you tell me? That is given as r rho v by 3 epsilon. This is what you tell me now here. This is the for 0 less than R less than capital R. And so here they are asking to find the electric field where. Now here capital R by 2 means this point lies where. So R is a radius of the sphere. R by 2 means where the point lies, inside or outside. So this point lies, this is at this location. We should find the electric field where. Inside we need to find now. So I have to use inside formula we have to use. So tell me now, what is the electric field when small r equal to R by 2, which is given as small r equal to R by 2. This is capital R. Rho v given as this rho naught coulombs per meter cube is given now. This is the volume charge density. So which is given as, what you tell me, by 2 will come 6 epsilon. Isn't it? Next, I need to find the electric field 2R. 2R means what now? What is the electric field outside? Outside the sphere, which is given as R cube, that is rho v by 3 epsilon into R square. This is outside now. So tell me now, what is the electric field when small r equal to 2R? So tell me now, capital R is a constant. Now here what is the variable parameter, you tell me? Small r is only the variable parameter, distance parameter. So what we'll get now here, 3 epsilon into what I can say, 4R square. Now you tell me now here what I will get. That is R rho v by 12 epsilon. Isn't it? Now you find, now they are asking to find a ratio between these two. Tell me the ratio between these two क्या आएगा? 2 by 1 आएगा, check करो. So the ratio between, if I take the ratio between these two क्या आएगा? 2 by 1 आएगा, check करो. Done? Completed all of you, tell me? Okay, fine. Right. Yeah. Fine, that's for the today's sessions. And tomorrow we have to discuss about the Poissons and Laplace equations. Okay then. I hope आज का क्लास में सभी को मजा आया होगा. Everybody enjoyed the today's class, I think so. Fine, all of you do like the sessions. All of you do like the sessions. So here whatever the amount of love you are showing, the same manner I will provide you, the best manner I will try to provide my classes also. Okay, and all of you try to share this to the maximum students and all. Ask them to join the live classes, or if not possible, ask them to do the recording sessions. Okay, so whatever the way you are showing love towards me, the same manner I will return back you definitely. Definitely आपको return gift मिलेगा. Okay, the best manner I will provide you. Okay, fine. Okay then, see you. Bye bye. We'll meet tomorrow.